See, in this part, we have to find PDE. PDE means partial differential equation by eliminating arbitrary function. Okay. In first part, you have learned how to find PDE using by eliminating arbitrary constant. This is arbitrary function, right? Yes. So you can see here fxy, fx plus y plus z x square plus y square plus z square is equal to 0. What do you do? Let this is u. Okay. Consider this function as u. Let u is equal to x plus y plus z. And this is v. Okay. Now you can write u v is equal to 0. Understood? Yes. Okay. First we find out uh, first we find with respect to x. Okay. Yes. Okay. Del u by del x is equal to 1. Del u by del y is equal to 1. Del u by del z is equal to 1, right? Del v by del x 2x. Del v by del y 2y. Del v by del z 2z, right? Okay. Now when you differentiate this function with respect to x, what will you get? F of u, because x contains in u and v also. So you can write f of u del u by del x, right? Plus del u by del z del u by del x. And you can write p. Similarly, f of v del v by del x vz del v by del x p, right? And what is del u by del x 1 plus p 2x plus 2zp is equal to 0. Now differentiate with respect to x with respect to y. So when you do with respect to y, sorry, this is x. With respect to y, what will you get? F of u 1 plus q f of v 2y plus 2zq is equal to 0. First equation, second equation, right? Now you can see you have to eliminate f of u and f of v. How? From first equation, f of u is equal to and from second equation f of u is equal to and you can see when you divide f of u, f of u, f of v, f of v cancel. Okay. 1 plus 2 Take 2 common, y plus z cube. 1 plus q minus 2 common, s plus zp. 2 to cancel. Opening the bracket. 1 plus 1 plus zq. Py zpq. X plus zp. x2 zpq cancel from both sides. Right, this is y. Understood? No. After rearranging, you will get y minus zq. Z minus xq is equal to x minus y. Okay, this is your answer. Right? Yes. See second question. What is second question? Z is equal to x plus 80, x minus 80. So first of all, find del z by del x. Del z by del x is f x plus 80 g x minus 80. Okay. Now find double derivation. So when you do double derivation, you will get same thing. X plus 80 gx minus 80. Okay. Now del z, find del z by del t. Here y is not there, t is there. So when you do with respect to t, you will get f x plus 80 into a g x minus 80 into minus a. Okay. When you do differentiation again with respect to t, you will get a into a square and minus minus plus a square. Okay. This is first equation, second equation, third equation, and fourth equation. This is very good. Okay. Hmm. Okay. You can simplify in more easy way. You can write f plus g. Let's suppose this is f plus g, first equation. This is also f plus g, second equation. This is af minus ag, third equation. And this is a square f plus g. Right? From second and yes, from second and fourth equation, f plus g is equal to what? From second and fourth equation. Del square del x square is equal to f plus g. F plus g is this. Put in fourth equation. Okay. So when you put in fourth equation, what will you get? Del square z del t square a square del square z upon del x square. This is your final answer. Understood? You can you can go through once. Then I will tell third one. Done. See, in third equation, this is arbitrary function. Okay. So first differentiate with respect to x. What you will get? F x log phi. Okay. Let's consider this is phi. Okay. You can write theta del square for your uh, easy calculation. Let's suppose this is theta. Okay, where theta is. Okay. And this is what P. So P is equal to first equation. Now differentiate with respect to y. 2y, 2 theta, and log y derivation is 1 by y. So q minus 2y is equal to, okay. From here and here, you are getting same thing. When you divide, you will get the answer. That's it. Right? When you divide, your purpose is to eliminate this part, f of theta. Okay? I think this will be derivation. Yes. Minus 2 upon x square. Okay? Your purpose is only remove this part. Anyway. So this is what? This is one function, this is other function. Eliminate f and g, right? First find del u by del x. Into 2x, right? Okay. 2x common, right? Differentiate with respect to y. right? Again, differentiate this with respect to y. Why? Because when again minus comes outside, it becomes positive. Understood? First equation, second equation. Okay. So put this value here. What will you get? Del u by del x is equal to 2x del square del y square. This is your answer. Understood? Try this question. Fifth. Find del u by del x. What will you get? Fxy gxy plus fx plus use u into v rule, right? Yes. Find del u by del y. Right? Okay. Still there is no chance to solve further. What will you get? Differentiate this once again. Differentiate with respect to um, okay. So what we can do? Uh, let's consider this is P and this whole thing is taken left side. F dash x plus y. Put here, okay? So when you put here, and this is Q, when you put here, you will get P minus fxy g dash x minus y. And the remaining part is fx plus y g dash x plus x minus y. And this is 2 times fx plus y. Okay? Yes. Again, differentiate this with respect to y. When you do differentiate it with respect to y, this is what? Del u by del y. It becomes del u by del y square. And this is p, right? So p means what? Del u by del x. We will get del square u del y del x minus differentiating with respect to y means fx plus y minus g double dash x minus y plus No, it will be very lengthy. 1 minute. I tell you in simple way. See, you have f x plus y, g x minus y, right? There are two arbitrary functions, so we need second order PDE. Okay, when only one arbitrary function is there, find only uh, first order derivation. Here two function is there, so find second order. Let's suppose this is alpha and this is beta, right? Yes. Find first order derivation. First order derivation means find del u by del x. F f of alpha, f of beta plus f of beta, f of alpha, right? Find del u by del y. F of alpha, sorry, g. This is g. Okay. Okay. Now see. When you find, you will get f of y, g of beta minus g of beta, f of alpha, right? Okay. Again, derivate this with respect to x. When you again derivate, you will get f double dash alpha, g of beta, g of beta, g dash beta, f dash alpha, plus g double dash beta, f of alpha plus f dash alpha, g dash beta. Okay. So from here you get f double dash alpha, g beta plus 2 times of g dash beta, f dash alpha, g double dash beta, f of alpha. Understood? Yes. Now find del y square. Differentiate again with respect to y. So when you differentiate with respect to y, what will you get? F double alpha, g of beta, g dash beta minus 1 minus g dash beta f of alpha plus minus plus. Okay. So from here you will get f double dash alpha. Okay. Now see, See, we have to eliminate f dash g dash from both equation, right? So when you add this, yes, when you add this, you will get add or when you take subtraction, you will get del square u upon del y square. Only for f dash f double dash alpha g double dash alpha will लेंगे. Okay. Yes. And after this, what you can do? When you do subtraction, plus, you will get 0, right? So on adding, understood? Yes. So anyhow, you have to eliminate this. Okay. See third question. Hmm. See third question. right? So uh, try third. You you have to find only du by dx and put here. Du by dy put here. Du by dz put here and simplify whether this is coming 0 or not. Check this. First, you understand what is Lagrange form. This is called Lagrange form. P small p q small q is equal to r. Okay. When any equation comes in this form, it is called Lagrange form. Understood? Yes. First, we find from the from this equation. And what is PQR? P Q R, big P, big P, big Q, big R are functions in X and Y. Okay. See, from first equation, first find small p. Okay. See this. First equation, this is what? Capital P. P plus Q, Q is equal to R. Tell me what is P? X plus Y square, right? What is Q? Y. What is R? Z plus X square, right? Yes. Now see how to find Lagrange equation. This is general form. Dx is equal to P dy q and dz r. This is called auxiliary equation. First we find auxiliary equation. Okay. When any equation comes in this form, first we find auxiliary equation. What is auxiliary equation? Dx p is x plus y square, dy q is y, dz r is z plus x square. Right? Yes. See, you know, A is equal to B is equal to C is nothing but A is equal to B, A is equal to C, and B is equal to C, right? So from here you will get three equations. First equation is this, right? Yes. Solve this. How will you solve this? Dx is equal to dy x plus y square dy. Okay. Dx upon dy is equal to x upon y plus y, right? Dx upon y, x minus y is equal. Okay. This is what? Linear differential equation. And you know how to solve linear differential equation? First we find its IF. IF means integrating factor. Integrating factor is what? E raised to minus 1 by y dy. When any equation is this form, it's called linear differential equation. I think you remember this, right? So IF is 1 by y, right? If IF is 1 by y, then multiply with x. So x into IF. So y into 1 by y dy plus, right? Multiply y on both sides. And you can also write what? C is equal to x upon y minus 1. This is first equation. From first part, you got first equation. Okay. Now we will try for second equation. What is second equation? Okay. Dy upon y dz z plus. What is the value of x from here? X is nothing but c y plus y square, right? So put here c y plus y square, right? Okay. Anyhow, you have to call this dy z cy plus y square upon 1. So dy by dz minus z by y c plus y. Find integral of integrating factor of this. So this is what e raised to minus 1 by y dy. IF. What is the complete solution? Z into IF Q into IF dy plus C2. Let's suppose this is C2. So Z upon Y ln Y C ln Y plus Y plus C2. Understood? From here you got C2 is equal to. Okay, so final answer will be C1 comma C2. What is C1? X upon Y minus Y, Z upon Y minus C, and then Y minus Z is equal to 0. This is your solution. Understood? Okay. Now see very carefully. I will tell second question, and you can try for third. Okay. In this type of problem, you must have knowledge of how to find differential equation. First, I tell the basics of linear differential equation. If any question comes in this form, where p is any function and q is any function in x, then first find if. What is if? Integration of p dx. After finding if, this is complete solution. Y into if, q into if. Yes. So in this type of problem, you will need this. That's why I told you already. Now see, my focus is on how to solve Lagrange equation. You know Lagrange equation is this form. What is big P here? What is Q? And what is R? Understood? When any question comes in this form, try to write in this form. Okay. What is P? X minus. Okay, right? So you will get three equations. First equation will be okay. First we will try to solve this problem. Okay. Y square minus ZX. Up to here you understood? This is first step for comparing. This is second step. After putting second step, we will solve one by one. Okay. Okay. In each term, you can see x, y, z, x, y, z, x, y, z is there, right? So you cannot solve this by uh, integrating one by one, right? So what do you do? See, find p minus q. What is p? When you simplify, you get x minus y, x plus y plus z, right? Yes. Okay. So you can write dx minus dy upon p minus p. So dx minus dy, dx minus y, x minus y, x was x plus y plus z. If you consider x minus y is equal to u, so what you can write du ux plus y plus z. Okay. Now this is first equation. If you find p plus q plus r, what you will get? X square plus y square plus z square minus xy minus yz minus of z. Right? Yes. So when you find dx plus y plus z, p plus q plus r. Okay. P minus q, you are getting this, right? If you find q minus r, you will get y minus z, x plus y plus z. R minus p, z minus x plus y plus z. Okay. See, when you solve this, you will do what? When you do take integration, you will get log x minus y, y minus z. Let's suppose this is c, or you can write c1. So c1 becomes log x minus y upon y minus z, right? Okay. Now when you find dy minus z, dz minus x. So from here you will get log y minus z minus log z minus x is equal to c2, where c2 is equal to log y minus z minus x. Final answer will be c1 c2 is equal to 0. Put c1 c2 is equal to 0, right? So c1 is what? Is equal to 0. This is the answer. Okay. Now can you try this third one? Okay, 1 minute. Hey, this is P, this is Q, this is R. What is P? Okay, you know, this can be solved easily, right? That's why first we take this part. 2x, 2x cancel, right? Yes. That's okay. This is x, y, z. I written it. Now see, when you take integration, you'll get log y, log z plus c. Let's suppose c1. What is c1? Log y minus log z. Log y upon z. Right? Yes. And when you take, you can write e c1. mm, This is first equation. Okay. You can further simplify how. You can write what? Z. This is e raised to c1 y by z. Right? For removing log. So z becomes y. E c1 is one new constant. So you can write here c only. Right? So c z zc is equal to y. Right? Understood? Yes. Now solve this part. Hey, Babu, Babu. Okay. Okay. Now see, z is equal to y by c, right? Put here. y square by c square 2xy, right? Divide by 2xy on both sides, you will get x upon 2y, 1y cancel, y upon 2x, y upon 2xc dy, right? If this part is not solved, then take this part. Let's try this. Dx upon x square minus y square minus z square. What is z here? See, the variable comes in x and z. So we have to eliminate the value of y, right? Not z. And what is the value of y? zc. Z square c square minus z square 2xc. Okay, let's see. Hmm, okay. Dx 2xz, right? And this is x square minus y square minus z square. Actually, this topic is very difficult because you have to thinking a lot how to eliminate and how to, yes. Now, when you open the bracket, x del x plus y del y plus We will try to make this into this form. Why? Because this is standard trick which is used in multiplier. So you can see x dx, right? Let's suppose this is what x p y q r z z r. So put the value of p, q, and r. Okay, what is p? What is q? And what is r? Okay, when you open the bracket, you will get x cube, x y square, x z square, 2xy. On simplifying, you will get yes. Okay, now it becomes easy. X dx, y dy, z dz upon x, x square, y square, z square. Okay, now this part cancel, right? Or you can write what? Let x square plus y square plus z square is equal to u. Okay, so you can write what? Du x du. And this is what? Du x du dp. Okay, du by du to dx. When you integrate, you will get log u to ln x plus c. So u becomes cx square, right? This is quite lengthy. Final answer will be c1, c2 is equal to 0. Where c1 is what? C1 is y by z. Sorry. C1 is y by z, yes. And C2 is put the value of you will get x square plus y square plus z square upon x square is equal to 0. Okay. When we will do revision, I will tell you when. Right now, see how it is going to be solved. Okay, give me 1 minute. I am just starting the system. You can listen because my digital pen is not working after one. It becomes slow.